In this video we examine subsidence inversions. These are inversions that form by subsiding air which warms due to adiabatic compression. The top of a subsiding layer warms more than the bottom of the layer because it descends further, and that's illustrated in the schematic on the right hand side. You can see the top of the inversion descending a long way compared to the bottom of the inversion. So they're the two green lines indicating the middle red dots. You can see how the atmosphere is compressed as represented by the two rectangles. So the initial rectangle is quite tall, and after subsidence it becomes compressed. So the inversion is produced by compressional warming or adiabatic warming. Subsidence inversions are associated with high pressure systems because in the southern hemisphere on the eastern flank there's significant pole to equatorward motion, and that's associated with subsidence. As well as the pronounced warming, there's also a pronounced drying because as the air subsides it advects down drier air from further up in the atmosphere. So here's an example, and you can see an inversion on 2 successive days. You can see how there's been increased subsidence between the 2 days, resulting in a lowering of both the inversion in terms of the dew point temperature and the temperature. The inversion's at about 5,000 feet. You can see there's a very shallow moist layer just underneath the inversion, and above the inversion there's very strong drying. Here's another sequence. The magenta trace is on 23 UTC on the 16th, and the yellow trace is on 23 UTC on the 17th, and you can see how the inversion has dropped over time. The final trace at 11Z on the 18th, the lowest inversion is actually a radiation inversion. But you can see how the inversion can change over a period of a day or so, can lower quite significantly. Here's a sequence of events showing an inversion forming in Adelaide. So on 00 UTC on the 27th, there's a low pressure system just to the south of Adelaide, and there's a strong south to southwesterly flow. On 00 UTC on the 28th, Adelaide's under the influence of a high and continuing into the 29th. Stop the video now and describe the major features of this trace. What cloud and weather do you think is possible? How did you go? You should have noted that between the 27th and the 28th we get the formation of a strong inversion near 800 hectopascals in both the temperature and the dew point temperature. This is a change from the moist layer that existed the day before with an inversion much higher up in the atmosphere. We now have a much shallower saturated layer just below the inversion, and so that's likely to be associated with stratocumulus cloud. It's possible that that might be associated with some drizzle, although given the depth of cloud it's probably unlikely in this case. Very often you get what's known as anticyclonic gloom, and that is a shallow moist layer of stratocumulus capped by an inversion. Here's the same trace that we saw earlier, and on the inset there's a satellite image, and you can see a large sheet of stratocumulus cloud in that. So between the subsidence inversion and the beginning of the saturated and near saturated layer you have the formation of stratocumulus cloud. It just so happens in this trace too there's a radiation inversion near the surface. There's light onshore winds below the inversion as well, advecting the stratocumulus onto the coast. And again, depending upon the depth and the temperature of the SC, we could also get drizzle, but in this case it doesn't look particularly likely. So that's the study of subsidence inversions and their impact upon the weather.